Good morning students and welcome to the new module of class 8th, chapter number 8, comparing quantities. So, in the last class we deduced the formula for the compound interest and solved a question of compound interest. Now, this rate was compounded annually. Now you may want to know why compounded annually was mentioned after rate. Okay, does it mean anything? Yes, it does, because we can also have interest rates compounded half yearly or quarterly. Let us look at one question and try to understand what do we mean by compounded annually, compounded half yearly or compounded quarterly. So, we will solve questions and we will try to understand this concept of compounded half yearly and compounded quarterly. Okay. So, example 12. All of you mark your attendance and then we will start with example 12. Example 12, what amount is to be repaid on a loan of rupees 12,000 for 1.5 years at 10% per annum compounded half yearly? What amount is to be repaid? Example 12, what amount is to be repaid on a loan of rupees 12,000 for 1.5 years at 10% per annum, 10% per annum compounded half yearly. Compounded half yearly. Okay. So, here principal is given, the time period is given, rate is given and compounded half yearly. Rate is compounded half yearly. So, how to solve this question? We will see that, and before starting the solution, let us understand the question first. Okay. So, principal is 12,000, time is 1.5 years, this time is 1.5 year, and the formula for compound interest or the compounded amount, A is equals to P into 1 plus R upon 100 power N or T. A is equals to P into 1 plus R upon power N. Okay. This N represents the time period. N represents the time period. So, if we take power as 1.5, we cannot multiply. Okay. The power, when the power is in fractions, like let us substitute the values in the question here. Formula, rate is 10, okay. After substituting the value of t, we cannot go further, we cannot write the next step because the power is fraction. If the power is a whole number, we can multiply that many number of times. Like if the power is 2, we can multiply this number in the bracket 2 times, okay, and we can solve the question. But here the power is a fraction, so we cannot solve it further. We should stop here. So to solve this problem, what we are going to do is, this rate, this is 10% per annum and compounded half yearly. Rate is compounded half yearly. So what we will do, we will divide this time in half years. We will divide this time in half years, okay, and after dividing the time in half years, the time period which we get is 3. The time period which we get is 3. In 1 year there are 2 half years. Half year plus half year makes 1 year. Therefore, 2 half years are there in this one, and this is another half year. So total 3 half years. So T is 3. Time period is 3. Time period becomes 3. And rate is 10% per annum. Rate is for 1 year. So we have to divide it by 2 to make it for half year, to make the rate for half year. So now to solve this question, what we have to do, we have to divide the time period. Time period n is equals to 3. N is equals to 3. N is 3 and the rate is 5% per half year. 5% per half year. Per half year. Okay. Now we can substitute the values in the formula and we can find out the answer. So A we have to find out. P is 12,000. Then 1 plus rate is 5 upon 100 and n is 3. Now we have simplified it and we can solve it further. We can multiply this. It becomes 21 upon 20. Okay. 12,000. This is 105 upon 100 power 3. So we can divide by 5 both numerator and denominator. This becomes 21. 12,000 21 upon 20 cube. 21 upon 20 cube. Okay. Though we can multiply 3 times 21 upon 20 and get the answer 13,891. 13,891. 0.50. So all of you understood what we did here. 13,891.50. Elsa Justin. Good. So here what we did, we converted the time period in half years. We converted the time period in half years, and then accordingly we converted the rate also. We converted the rate also accordingly. So when the rate is compounded half yearly, we are taking time period in half years, and accordingly we are changing the rate. For if the rate is given for 1 year, we divide it by 2 to make it for half year. Okay. So this is how we can solve when the rate is compounded half yearly. Now what will happen if the rate is compounded quarterly? What will happen to the time? What will happen to the time? What will be the time period if the rate is compounded quarterly? Write your answer in the live chat. What will happen to the rate and time? What will happen to the time period and rate when the interest is compounded quarterly? Interest is compounded quarterly. Time will be 1/4. So, what Anushree Maheshwari says, time will be 1/4. So, what will be the time period for this question? What will be the time period for this question? Right? How many 1/4s are there? Okay, time period, okay, we will make 1/4, but how many 1/4s are here in this time period? How many 1/4s are there? Six. Anushree Maheshwari, 6 1/4 are there. Good. There are 4 1/4 in whole. In this whole number 1, there are 4 1/4 parts. Okay, and there are 2 in this half year. So 4 plus 2, 6. Time period becomes 6. And what will be the rate then? What will be the rate? Rate, what will happen to the rate? What will be the rate? What will be the rate when amount rate is compounded quarterly? Write your answer in the live chat. What will happen to the rate? Anushree Maheshwari says rate becomes 1/4. Yes, 10 into 1/4. We will divide 10 by 4. It is what is the answer? 10/4, 5/2. So 5/2 is 10/4, 5/2. 2.2. 2.2. 2.5. 2 2s 4, 1.05. Okay, 2.5. The rate becomes 2.5. Okay, or we should not write the rate in decimals. We should keep the rate in fraction to solve the question easily. Okay, we should not write the rate in decimals. We should keep the rate in fractions only to solve the question easily. Is that clear? Write your answer in the live chat. We should not write the rate in decimals. We should keep the rate in fractions only. Okay. Now let us look at example 13. Example 13. Example 13. Okay. Find compound interest paid when a sum of rupees 10,000 is is invested for 1 year, is invested for 1 year and 3 months, at 8.1/2% per annum compounded annually. Compounded annually. Here we see that the principal amount is 10,000, time period is 1 year 3 months, rate is 8.5% per annum and rate is compounded annually. So, rate is compounded annually. So, we should convert how to find the compound interest, how to find the compound interest. So, what we will do in such case where the time period is not in whole numbers, when the time period is not in whole numbers, then what we have to do? We have to find the compound interest for the whole number of years. Okay. So, here we have only 1 year. So, we will find the compound interest for 1 year and then we will find the simple interest for 3 years. Then we will find the simple interest for 3 years. Okay. So, this is the thing which we should keep in mind for such type of questions where the interest is compounded annually, but the time period is not in whole number of years. Okay. So, here let us convert this percentage rate, let us convert this rate in improper fractions. This is a mixed fraction, let us convert it into improper fractions. It becomes 8 into 2 16, 16 plus 1 17 upon 2. Rate becomes 17 upon 2. Okay. So, let us find out the compound interest. Okay. So, A amount is equals to P 10,000 into 1 plus rate is 17/2. So, 17/2 into 100 power 1. Okay. So, first we are finding for 1 year and then we will find the interest for 3 months later. Okay. So, when we solve this, we get 10,000 into 217 upon 200. Okay. This is equals to 10,850. 10,850. This is the amount after 1 year. So, compounded annually. So, this will act as the principal for the next 3 months. Okay. So, now while calculating these 3 months, we use simple interest. Simple interest is equals to P into R into T upon 100. Okay. So, principal is this will act as our principal 10850 and rate is 17 upon 2, rate is 17 upon 2, then time. So time here we should write in years, because this rate is for 1 year, we have to write this time in years. So 3 months will be equal to 1 by 4th of a year. 3 months is equals to 1 by 4th of a year. So 1 by 4 into divided by 100, divided by 100. Okay. So when we solve this, we get rupees 230. When we solve this, we get rupees 230.56. When we solve it, we get rupees 230.56. So we have to find the compound interest. So interest for the 1 year is 10,000 minus 10,850 minus 10,000. So 850 rupees here, 850 rupees here, and 230 from here, 230.56, 230.56. So this will give us the compound interest, 1080.56. Okay, so compound interest is 1080.56. All of you understood this question? Write your answer in the live chat. All of you understood this question? Yes? Okay, let me explain it once again. So here the principal is rupees 10,000, principal is rupees 10,000, time is 1 year 3 months, and rate is 8.5% per annum and compounded annually. Okay, so here the rate is compounded annually and the time period is not in years, time period is not in years, and rate is 8.5%. So first of all, we have to convert the rate into the improper fraction, and then here we have 1 year and 3 months. So first we will find the compound interest for 1 year, and then we will find the interest for the 3 months. So amount is equals to 10,000 P into 1 plus R upon 100 power n, n is 1. So when we solve this one, we get 10,850. So interest, compound interest for 1 year is 10,850 minus 10,000, which gives 850. Now for the rest 3 months, we have to find the simple interest. Now this amount will act as the principal for these 3 months. So principal is 10850, rate is 17 upon 2, and time is 1 by 4 upon 100. When we solve this, we get 230.56, and when we add this 230.56 to 850, we get the total compound interest for 1 year 3 months. So which is 1080.56, 1080.56. So we have seen that what do we mean by compounded annually, compounded half yearly, and compounded quarterly. Okay, and we have seen what to do when the time is given in months, when the time is given in months. Now applications of compound interest formula. Example 14. Example 14. Example 14. The population of city was 20,000 in year 1997. Okay. It increased at the rate of 5% per annum. 5% per annum. Find the population at the end of year 2000. Find the population at the end of year 2000. Okay. This is the application of compound interest. So here principal is given as 20,000. Okay, and time period is 3 years, 98, 99 and 2000. Okay. So time period is T is 3 years. Time period is 3. Okay. Rate is, so we have to directly use the formula, which is equals to, let the population in 2000 be A. So A is equals to P into 1 plus R upon 100 power 3. Okay. So 20,000 into 1 plus 5 upon 10 power 3. We can simplify it further. This is 10 plus this is 100, 5%, 100. So 105 upon 100 power 3. Okay. So this is 20,000 21 upon 20 power 3. Now this is equals to 23,152.5. 23,152.5. Okay. So estimated population is 23,153. 23,153 estimated population. All of you understood? All of you understood the application of compound interest? Write your answer in the live chat. So population in 2000 is 23,153. Let us look at one more application of compound interest. Example 15. Example 15. Example 15. A TV was bought at a price of rupees 21,000. 21,000. After 1 year, the value of TV was depreciated by 5%. 5%. Depreciation means reduction of value due to use and age of the item. Okay. Find the value of TV after 1 year. Find the value of TV after 1 year. T is 1 year. Okay. So principal is given, rate is given and time is given. We have to find the A after 1 year. Okay, so here instead of adding we are going to subtract. Instead of adding we are going to subtract. So value at the end of 1 year is equals to principal into 1 minus rate 5 upon 100 power 1. 1 minus 5 upon 100 power 1. So this is 21,000 into 19 upon 20. 21,000 into, so this becomes 19,950. The value of the TV after 1 year is 19,950. Okay. So we have solved sufficient number of questions to understand the compound interest. So let us see how this compounded annually, compounded half yearly and compounded quarterly are similar and different from each other. Okay. So we will compare the compounded half yearly and compounded annually, and we will see in which rate we are getting the more compound interest, more interest. Okay. So let us see what happens to rupees 100 over a period of 1 year if 100 rupees over a period of 1 year if an interest is compounded annually or half yearly. If the interest is compounded annually or half yearly. Okay. Let us see what happens to rupees 100 over a period of 1 year, if interest is compounded annually or half yearly. Interest is compounded annually or half yearly. Okay, so we will see for two cases, compounded annually and compounded half yearly. So let us solve. So P is rupees 100 and rate is 10% per annum compounded annually. And here we have P is equals to 100, principal is 100 and rate is 10% per annum, compounded half yearly. Compounded half yearly. This is compounded annually and this is compounded half yearly. So time period is taken as 1 year. So interest will be equal to PRT upon 100, which is equals to rupees 10. Okay. So amount after 1 year will be equal to 100 plus 10, which is equals to rupees 110. So this will be the amount after 1 year. So this is the simple interest. We can find out the compound interest like this. Let us find out the compound interest. Amount is equals to principal into 1 plus rate is 10%, 10% per annum is 1. So 100 into 110 upon 100. So this 100 and 100 gets cancelled and we get 110 rupees. So in both the cases we are getting 110 rupees. Okay. If we do using simple interest, we get 110 as the amount. If we use the compound interest formula, then also we are getting 110 as the amount. Now let us look at this part where the compound interest is compounded half yearly. Okay. So time period is 6 months or half years. P is equals to 10, compound, this 10 is per annum. So when we compound it half yearly, it becomes 5%. 5%. Okay. And time period becomes 2. Time period becomes 2. So let us see. A is equals to P. P is 100. 1 plus rate is 5 upon 100 and power 2. There are 2 half years. So this is 100 into 105 upon 100 power 2. So this is 100 into 1 point. This is actually 21 upon 10. 21 upon 10 into 21 upon 10. So these zeros gets cancelled and we are left with 21 into 21. So 21 into 21. Wait, we have done something wrong here. Okay, so principal is rupees 100 and rate is 10% per annum and compounded half yearly. So time is 2 and rate is 5. Rate becomes half. So amount will be equal to P into 1 plus rate is 5 upon 100, 5% power compounded half yearly, year 2. So with this is equals to 10, 100, this becomes 100, 5 upon 100 power 2. So this is 100, 21 upon 20 power 2. So 100 into 21 upon 2 into 21 upon 2, 20. So these zeros will get cancelled and we get 21 upon 2 into 21 upon 2, which is equals to 21 into 21, 441 upon 4, 441 upon 4. One one 0.2 5, 110.25. So we see that this is 110.25. So we see that when the amount is compounded annually, we are getting rupees 110, and when the amount is compounded half yearly, we are getting rupees 110.25. So we see that the amount in compounded half yearly is more than the amount in compounded annually. Similarly, amount in quarterly, amount in compounded quarterly will be more than the amount in compounded half yearly or compounded annually. So the shorter the time period, greater will be the amount. Okay, shorter the time period, greater will be the amount. So in this session we learned about the compound interest when it is compounded annually and also half yearly, compounded half yearly, and then we saw the application of the compound interest formula. We saw the application of compound interest formula. So by this we finish all the concepts of this chapter which we should have learned, and only exercise questions are left which we will discuss in the upcoming sessions. Okay. That's all for today's session. If you have any doubt, you can ask in the live chat. Okay. So thank you.